Now that our figures are ready, let's evaluate the total distance using the formula for all the various figures that we look at in the previous session. Right? We say there are going to be three main ones: triangle, trapezium, and rectangle. The rectangle can come like a square as well. So in this session, we have them already. We have actually demarcated everything. Let's go and solve them. So first, you just identify what kind of figure you have, and you're able to get the corresponding formula to evaluate it. So here, what do we have here for this particular one? You can see that we are having a triangle. It's in this form. Triangle in this form, right? So we say if it's a triangle like this, we are going to talk about triangle. The area for a triangle is half base times height. It's a right angle triangle, specifically right angle triangle. For right angle triangle, we have half base times height, and the base is going to be the down here. The down here, the B, and our height is going to be this side for this triangle because it is 10 like this. So our height is going to be this one h. So let's evaluate the height h. The height h is the difference from the down here to the distance. Because it's a height, you need to measure it on the vertical axis. So on the vertical axis, it's going to be this separation here, which is going to be the height. So the height from 0 to 20, that will be an interval of 20, or you can do 20 minus 0 to get 20. So our height is equal to 20. What about our base? Our base is going to be from here to here, right? So from here to here, it's going to be 5 minus 0. 5 minus 0 will give you 5. So our base is equal to 5. So using the formula, we have half times the base. You see the base is what? 5, right? Times the height, which is 20. So if you do this, we are just going to basically have 50. So 50 units. 50 units. Because its velocity against time is going to be 50 meters. You are basically going to have 50 meters as the answer for this. So this particular distance, the total distance is 50 meters. The next one, this is another triangle, right angle triangle, but it is turned like this. Right? Do we see that it is turned like this? So we are going to have our base here and our height here. So the height is usually measured from the vertical axis or the y-axis. So 30 minus 0, that will be 30. So the height is 30 and the base is 6 minus 0, which is going to be 6. So the area will be equal to half. That means the base is 6 times the height, which is 30, right? So half times this are going to be 3. So you're going to have 90 meters. So this is the total distance for this particular graph. Basically, that we have triangle. Now we have this. Here we said we're able to demarcate. We have two portions. This one, there was a right angle triangle on this side, and at this side we also have rectangle. So let's get the area for this. Let's say call it area 1 and get the here this one area 2. So let's get for area 1. Area 1, what do I have? Half base times height because it's a rectangle. Half base times height. Half times the base is from here to here, right? 3 minus 0 is going to be 3. What's going to be the height of the rectangle? We're just focusing on the rectangle. So the rectangle is going to be this height here. You measure the 15 minus 0, it's going to be 15 as well, right? So if you measure the 45 divided by 2, you're going to have 22.5. So for area 1, it's going to be 22.5 meters. That's just for the rectangle, for the right angle triangle. Now for the rectangle, it's going to be this, right? For rectangle, we see the formula, which is area 2 is equal to the length times the breadth, right? So what we have for the width is here, which is the same as the height. So 15 minus 0. So basically, the breadth is going to be 15, and the length is going to be from here to here. From here to here for this rectangle. So it's going to be 7 minus 3. 7 minus 3 is going to give us 4. So 15 times 4. So 15 times 4, that will give us something like 60. So area 2 is 60. So the total area will be equal to area 1 plus area 2, which is 22.5 plus 60, which is going to be 82.5 meters. This is the total distance traveled. Another way of calculating this is also looking at the whole thing as trapezium as well, or trapezoid. So I'm going to try that as well. If you consider the whole thing as trapezium, we are going to identify two things. So you say trapezium is, for trapezium, area is equal to half times the height times the sum of the parallel distances, right? Parallel sides. So this one, this side from here to here is parallel to from here to here. You see, they're all straight line, straight line. So parallel. It doesn't need to be equal in length. Don't have to be equal in length. They just have to be parallel. So they all follow the same direction, right? So this is side A, this is side B. Right? They are parallel, but they are not equal in length. All right, that's what we mean. So A is going to be from here to here. That's 7 to 3. That was going to be what? 4. Right? So I'm going to have A is equal to half into bracket A is 4 plus from here to here 7 to 0, right? It's going to be 7, and then times what's the height? The height is going to be this side. The distance between the parallel side. The height is the distance between the two parallel sides. Yeah. So you're still going to have 15. Yeah. If you do this, you are still going to have 82.5 meters. This for the two. So that's the two ways of doing that. You can look at this as a triangle, or you look at it separately, area 1, area 2, and evaluate to get the same responses. For this one, you can also decide to divide this. So this is area 1, divide this as well, like area 2 for a rectangle or a square, and then area 3. But then we can also look at the whole thing as a trapezium and directly evaluate. So how do we solve that as trapezium? So you are challenged to actually solve it in the direction of area 1, area 2, area 3, but I'm going to solve it as trapezium space. Area is equal to half base times its height. So half times A plus B. So the A, let's say this one is A and the B is B. From 15 to 0, right? So it's going to be B is 15 plus A is going to be so this side, I think, where did I stop? I think that's 10. So I think 11. So this is 11 to, this is 4. So 11 to 4, right? 11 minus 4, that's going to give us something around 7. Yes, 7. So that will be going to be 7 times the height. The height is the separation between the two. The separation between the two is 20. So if we do that, 15 plus 7, they are going 22 times 10. It's going to be 220 meters. That is the total distance covered for this particular graph. Let's solve this last one that we did. This one. So when we were doing this one, we said that okay, we have trapezium here, rectangle here, trapezium here. So we are going to solve the trapezium ones at area 1, area 2, area 3, right? So for area 1, we're just going to try that, and whatever you get to put in the comment section, let's see if you actually got it correct. So for the area 1, what you do is that for the trapezium, we are going to have the base is going to be what? So sum of parallel side, which sides are parallel? So this side is parallel to this small side. I said for parallel, they don't have to be equal in length. They don't have to be equal in length. They just have to be parallel or follow the same direction. So this is it. So this side is parallel to this for this particular A1 trapezium, the red section. So it's they are both parallel. So for the parallel side, we are going to put in the bracket. So this to this, we are going to have 50 minus 0. 25 minus 0 is going to be 25 plus. For this small side, it's going to be 10 because from here to here, so it's 10. Then that's the sum of the parallel side times the height, the separation between the two parallel sides. The separation between the two parallel sides. So the parallel side is here, right? And the another parallel side is here. So the distance between these two parallel sides is what is your height. So you see the original one, the parallel sides were top and down. So we're able to get the vertical from here. But here, the parallel sides are now standing vertically. So you need to get the separation horizontally. So here, the separation is going to be from 5 to 0. 5 to 0 is going to be 5 as well. So this is for area 1. So you put this in the calculator, and you get what you get. You do that for area 2. For area 2, which is for the R, it is a rectangle, right? Length times breadth. And then when you come to the trapezium, this is going to be one parallel side to parallel to this. And the separation between them will be from this side to this side. So the height is going to be 15 minus 11. So we get 4. This parallel side is going to be 25 minus 0. And this parallel side is going to be 15. This one is 15 minus 0. That's what you get for this parallel side. That will be your area 3. So if you go there, you sum this to this and to this, then you have your final answer. Put it in the comment section. Let's see what you get. Yeah.